Thank you. Well, good morning or good afternoon, and I guess I'm the last person standing between you all and lunch, so I could short circuit part of the speech by asking. There's been some discussion of data storage. Wim brought that up, and there's some cableless systems out there that are talking about cableless cabled seismic acquisition today using mainly memory techniques. Our thesis is quite simple, that real-time data matters and that it's pretty imperative. So let me just ask for a quick show of hands. How many people would prefer to get their data back in real time, if they could, on a cost-competitive basis? Okay, I guess I could end now, but that wouldn't be very much fun. So. We all know the story about the requirement for eliminating cables. Most LTIs on seismic crews are caused by trips, slips, and falls, mainly due to neck rolling cables in many areas. And obviously, if you can eliminate the cables, you'll get more uptime, less cable troubleshooting in the mornings, and safer operations. We've also are all very much aware of the increased environmental pressure for less footprint, for less line cutting in areas that require line cutting. This goes without saying. I think everybody in this room would accept that there's a strong case for this direction. And so, road and river crossings become a breeze if you do have a cableless system. Again, so no argument there. I think we're all on the same page, and this demonstrates on your left a mule out in West Texas carrying approximately the same number of channels as the truck and trailer on the right. It illustrates Wim's point. This gets scaled to very, very large numbers in the Middle East crews. And so you capture some gains in efficiency, which goes towards the cost points that David talks about. And I'm gonna digress from my prepared remarks to address a couple of David's points here in just a second. But this brings up the question: what about my data? Because we are geophysicists, and oil companies are hiring contractors to get the data back. So we think that that's pretty important. Let me digress for just a moment, though. I didn't expect anything else from David. Faster, cheaper seismic. He's been on that broken record for at least 2 decades. So I wouldn't have expected anything else. And we're here to help. Wireless Seismic is here to help in that regard. But let me throw out some slightly different numbers. You referred to $3,000 a kilometer squared in the Gulf of Mexico, and I'm going to refer to some numbers from the shale resource plays in North America. The acquisition cost per acre in North America to get the lease runs $3,000 to $5,000 per acre. So the business to be in is to be a ranch landowner, leasing your land to the oil companies. That's the best business around in the oil patch these days. They call them shaleonaires. They're minting shaleonaires in the States right now, where you get to lease your land and keep running cattle on it at the same time. So seismic acquisition in the shale plays runs between $50 and $160 an acre. So for those of you challenged by conversion, I've already done the conversion. 1 square kilometer is about 247 acres. So at $50, at $25 an acre, that works out to $6,125 per acre. There are seismic surveys being shot today in the shale resource plays onshore for that amount of money. And in some areas it's as much as $100 or even $200. So at $100 an acre, that would work out to $24,700 per square kilometer. So again, the real problem is comparing onshore and offshore numbers is that terrain, the differences in terrain, the variability in terrain is much greater than what you get in variability of sea state. So that's why there's always going to be a wider range in land seismic costs. So let's come. Another thing I'd like to point out is gravity gradiometry runs $2 an acre, or $500 a square kilometer. And so I understand that Karen has used some gravity gradiometry techniques in Greenland recently, Tullow and others have used it down in the rift areas in South America, in Africa, and so that's another geophysical method that if you haven't already had ArcX here, you probably should. Okay, so our value proposition is quite simple. Cable-free systems with memory storage have some value. I won't put any numbers on this, but we believe that our value proposition is predicated on the sum of four things. Real-time QC, it's important. If you don't know what your data looks like in real time, it's hard to have the necessary confidence. We think there's a giant value in real-time seismic data recording, primarily because you can get a jump start on your data processing, which shortens the overall cycle time for the survey. This is a negative value in the sense that we are attributing positive value by not doing things, such as no data collection. Previous cable-free systems have been plagued. These are well documented, well known throughout the industry by data collection systems, which were onerous, and then data transcription. I hate to be the person trying to transcribe 1 million channels of data collected through flash memory and put them into proper order for data processing. That's a tough challenge. And then of course there is the data loss problem. One of our customers has already suffered range fires in the United States where a number of boxes which had memory storage in them were burned up, so they had to go out and reacquire the chute. You go out of the U.S. and into some other areas where theft can be a problem, and if you leave your units on the ground and with flash memory, if somebody wanders away with a box because they want to turn it into a cooking pot or something else, then you have not only a little bit of an inconvenience and have to call me to order another box, you have lost your data. Okay, so we think that that's a big value. So we think that we have a differentiated value proposition. So our system is very simple. We work with a rib and backbone system. So the rib would be a row or a line of what we call wireless remote units, WRUs, and then a wireless backhaul system. And we've done this in a rectangular linear architecture. But one of the beauties of going wireless, of course, is that we are going to free up all you geophysicists. We're going to free up your creativity. So we can imagine coil designs and circle designs and triangular designs and all sorts of designs that will allow for better geophysical attributes. One such thing that going cableless and wireless does is allow a variable density of line spacing. So that in your areas of greater interest, if you've highlighted some of these through, for example, a gravity gradiometry survey ahead of time, you might want to double up your density along the flex trend, where it's most likely to have natural fractures in either a shale play or a carbonate play. So we are both cable free, which by that we mean that we have no cables connecting our remote acquisition units. And then we're wireless in that we retrieve our data through a proprietary wireless network. The system components are the three basic components of any seismic system. The remote acquisition units, in this case it's a wireless backhaul. I do need to point out that at the SEG, where we introduced this system for the first time, we had a lot of feedback. A lot of people requested that we have a fiber optic cable for backhaul. So we've already put one in place and tested that, and that'll be ready to go as an option if somebody really wants that. The wireless data backhaul is not the bottleneck. What we have done, of course, is we've simply replaced a cable with modems. So the gate on the number of channels that we can hang off of any backhaul unit is gated by the capacity of the modem. So the really good news here is that we're able to leverage the advances, which is what Ian Jack pointed us to 2 decades ago, to the communications industry, and we're able to leverage that. So as modem speed increases, the number of channels that we can hang off of a backhaul system will scale accordingly. We're expecting 3 to 5 times increase in the very near future in that capability. And of course, a central recording system. Let's see. Okay, so for us, our real-time data delivery, this is a repeat of the previous slide. We do all of these things in real time, or don't do these things at all. Okay, so I didn't bring one with me, so this picture is going to have to do. But for those of you who were at the SEG, was anybody here at the SEG and actually saw the unit? Okay, you can hopefully attest that it's a rugged, it's a good-looking field unit. One of our erstwhile competitors, actually the giant gorilla in the marketplace, paid us the high compliment of walking in and saying that they were very impressed. They know how hard it is to do, and that this was clearly designed by field people for field use. So the guys were quite proud of that. It's a rugged antenna. Obviously, depending on your group spacings, you might want to go with a smaller, stubbier antenna. We have some people very interested in engineering applications that would have extremely tight group spacings. And so, in fact, we do a lot of our testing with stubby antennas. We have a GPS unit on there. We do not use the GPS in the unit for clock synchronization. We discipline our clock through the base stations and then use the radio network to discipline the clock. It works faster and with greater precision than the GPS clock, and allows us quicker cycle time. The status indicator lights, I've got another display on that, and I'll come back to that in a minute. But the point is that there is no handheld system required for deployment of the unit. It's intuitive. You look at the lights, and you can set it in place and move on. Now we're currently working with dual hot swappable lithium-ion batteries. And I'm going to go to another slide in a minute, but the box without the batteries weighs about 4 pounds. Okay, so this is very competitive. It's pretty lightweight and it's pretty robust. We have gone, for the time being anyway, with I would call this, being an old Western Geophysical, Western GECO guy, an LRS 3515. I realize it's the same connector. It's now called something different, of course, but it's an industry standard connector. You can plug in a string of geophones or a single phone. We have not gone for the digital sensor at this time. The batteries, of course, are extremely important, as Wim and others have pointed out. But let me first talk about deployment. It's the field crew that we had test this in West Texas picked it up almost instantaneously. It was a well-qualified field crew, and they picked it up instantaneously. It's very, very quick. What you do to activate the system is we use the accelerometer in the unit to turn on the electronics. So the entire system has been designed to maximize power, minimize power, maximize battery life. And so the way you turn it on is you hold it in a certain position with the GPS antenna up, and that'll activate the electronics. And so it turns on, and then you set it down and plug in the geophone, and it runs through an automatic series of self-tests, the geophone test. It'll check its GPS location. This is important to compare against a pre-plot. So the way that we form our lines is by we don't use an 82111 wireless protocol. We wrote our own because we needed to find one that would work better for seismic applications. So what we do is the unit will compare its GPS location to its pre-plotted location and say, oh, okay, here I am. I'm this unit, and it looks for its nearby neighbors. And then once it's done that, it goes back into a quiet state and waits for instructions. The good news is this whole process, it took me longer to explain it than it is to actually do it. And the juggy leaves knowing it's all good. Okay, so the other thing is battery display is shown, and these two batteries can read out, and you can see immediately, both on the ground and at the recorder, the status of the battery. So we decided to go for smart batteries and dumb chargers, and so we've to prolong the life of the lithium-ion cells. And this is a simple potted lithium-ion 6-cell system. We have the intelligence in the battery, so you can see the green lights are on. They're ready to go. They could be unplugged from this charging unit. The red lights are still taking charge. The nice thing is this unit here, which can hold 80 batteries, can plug into a regular socket in a motel room or a hotel room in the United States. Okay, so this you don't need a fancy charging truck. You might have a charging truck, but you don't need one because you can't plug into a wall. So it takes regular current. I won't bore you with all the details. We've got all those facts in our spec sheets if you'd like them. Why lithium-ion? Well, we will move away from lithium-ion at the proper time. We are actively monitoring energy densities, and there's some interesting technologies coming, and I think this will allow us to stretch it out. So how long a life do we get? Well, we get with 2 batteries, we expect 17 to 21 days in the field with the worst possible power consumption. We have about 8 levels of power consumption, and we will automatically step through the power to send the data back through the radio signals, depending on whether or not the packet retrieval is going according to our requirements. We would argue, we would put these specs up. I noticed WIM didn't show any specs, but we would put these specs up against anybody in the industry. Okay, and we would argue that these stand up and compare very, very favorably with anybody in the industry, particularly when you consider that our total dynamic range and our performance, performance is consistent over the entire temperature range which we specify. Okay, so it's not at typical conditions, which is normally at 72 degrees Fahrenheit. Our specs are published and proven over the entire temperature range. So it'll work in the Arctic and it'll work in the desert, and we're prepared to prove that. Okay, so here's our amplitude versus frequency spots. So I'm glad to see that people want sub 10 hertz and up to 200 hertz. We have a very, very flat response across this, and again, it's you'll get the same response in the frozen Arctic and in Oman. So how do we do our wireless backhaul? This is a straightforward system. There's lots of radio systems out there. We have worked with 3 to 5 vendors and chosen one with a backup to work with. And what we do is we basically put one base station unit per inline in order to form a cross line. So that's analogous to a Sercel line tap unit, if you want to think in those terms. And these antennas are man portable. They're about 20 feet, and one person can deploy it in about 10 minutes. Now the base station units do operate on standard batteries. We haven't seen the need yet. Most people have their cross lines in areas that are relatively accessible. So if there is a challenge in changing those batteries, we think that that's pretty straightforward. Each base station unit supports many wireless remote units. It obviously changes depending on your sample rate. At 2 milliseconds for typical parameters, we would have 120 channels off of a base station unit. That's our fundamental rib, is 120 channels. As our modems increase, that number will increase fairly dramatically, and we expect to see a significant jump next year. Okay, the central hardware is just what you'd expect. We can handle up to 8 monitors, 8 large panel monitors at present. It's a client-server architecture, works in Windows, TCP/IP interface, and the nice thing is we can output the data. We're thinking probably removable dual hard disks, which would be a nice simple way to move the data back and forth. Have a whole sequence of hard disks getting into the data processing center, and once done, we bring them back and recycle. So this is a typical patch that you would see, and you can mouse over any receiver location and pick up the wireless remote station panel display. This is exactly similar to what you would get if you were at the Juggy looking at the box. Okay, so you can immediately tell the battery status, battery A, battery B, and where you're at, and what's working and what's not working. So real-time diagnostics is important, we think. So the key question is, how do we move a lot of data a long ways? Okay, so what we do is, you know, there's been companies that have been formed, built, and sold on wireless technologies for seismic acquisition. We intend to be around for a while, so we'll see. But our technology is not a GSM technology. It's not a one-to-many. It is not an 80 to 11. It's fundamentally a short hop at a time. So we require our wireless remote units to talk to the next one, and that's it. So typical group interval, 25 meters, 50 meters. These antennas, with the antenna that you saw when I showed the picture of the wireless remote unit, we have seen antennas reach, we've seen signal reach up to a half-mile away. Okay, so there's no problem in reaching that far, but the only requirement is that even through heavy brush or in difficult terrain, we only need to get to the next box. So we use a bucket brigade technology. So this would be a backbone, and you know, if you had a base station coming into a cross line here, the way it works is that the last line in the unit relays its data. This one relays station number 1 plus its own all the way up the line. So as you can see, the one that has to work the hardest is the last one in line, because he's got to transmit everybody else's data. Okay, so the good thing about that is if you do have to go swap out a battery, and remember the battery lifetimes that I quoted were for the worst unit in the worst spot, which is this one. And they're closest to the cross lines. So if you do have to do a swap out a battery, they're going to be closest to your cross lines, because these are the ones that will have the heaviest use. So we think in most cases you'll be able to, almost all cases, you'll be able to wait to swap the batteries or charge the batteries when you pick up the spread. So we just do short hops at a time, and that's how the data comes in. And it's a scalable architecture. So while we're working out we've been working out the details, and 2011 represents a transition year from us. We're transitioning from a research and engineering organization into a full-blown commercial operation. We're going commercial this year. This quarter we're delivering our first systems to our customers. We've got 2 different customers and a third one in the wings. We're not advertising too much yet, because our initial run of manufacturing is already committed. And we want to get those into the field and get the feedback with our early adopting partners before we go. We see no problem in reaching the 50 to 100,000 channel range. We see no problem. Most of the market today, it's mandatory to have a 5 to 10,000 channel system. It's just mandatory. But we see no problem. We understand that my former colleagues at Western Geco have an 80,000 channel system in the field today. We understand where Wim Walk and Shell are going. One of the questions that comes to my mind is that really 1 million channels, or have you just unbundled the geophone string and treat each of those as an individual channel now? If it's the latter, it's really much more analogous to 100,000 channels today than it is 1 million channels. In that sense. So maybe we can talk after Wim. I'd love to hear. But we're scalable, and that's the beauty of the system. It'll just keep scaling. So we have recorded some live data. We haven't bothered with trying to process it. This particular, we will be doing that in the next few months, by the way, and we'll have publishing and show rights on that. This particular comparison was against an ARAM system, and there was a couple of traces inverted in here, and the normal thing. But the most interesting aspect is that compared to the ARAM, turns out that the ARAM when the time break starts, it freewheels its time, okay? And so we first had a question, well, it looks a little different down at the end of the record, and that's because we discipline our clock in real time, okay, even while the shot is going on. So we discipline our clock right through the record. So this won't show up on this scale of a plot, but we did notice that. So we've paid a lot of attention to make sure that the detail of the seismic architecture is correct from a geophysical perspective and from a field acquisition perspective. And we look forward to meeting people in the marketplace. Okay, so speaking as a seismic equipment manufacturer, I can't wait till people start ordering million channel systems. In 2008, there was just under 1 million channels sold. So at the approximate prices, that's slightly over $1 billion market. So we're excited because we believe that we're a disruptive technology in an established market, and that's a good place to be for an entrepreneurial startup company. We would expect cable-free systems. This is from our internal polling data to capture the desire from both the contractors and the oil and gas companies is certainly that up to 50% of the new purchases are going to go towards cableless and wireless systems in the next 3 to 5 years. So we're pretty excited about that. We believe, the numbers aren't in 100%, but we believe that approximately 7%, perhaps as many as 10% of the channels sold in 2010 were cable-free. A large number of those were infill systems. And infill is very challenging and more required. There are now municipalities in the United States requiring seismic contractors to go wireless systems or cable-free systems. It's a requirement. It's not an option. It's a requirement if you're going to work in their municipality. We think that trend will continue. We expect that by 2012, the market will pass 2008 in total volume, and we believe that we're pretty well positioned. So to reiterate our value proposition, we think real-time matters. And with that, I'll close. Wireless Seismic is a venture capital-backed startup company, and our earliest backer was Chesapeake Energy, and our newest partner in funding is Energy Ventures, and we're glad to have both of them on board. So we're rolling out thousands of channels this year, primarily under our preferred partner program, and we're looking to go full-scale commercial late this year, early next. Thank you for your attention.
And just to be clear, your business model is to be a manufacturer rather than putting wireless seismic crews out there.
I'm happy to take orders. Our business model is to sell equipment, and we're happy to take orders. Okay. And thanks for the chance to make the pitch, David.
Right. Anybody got any questions? Okay. We've obviously done a stellar job in convincing.
No, they want lunch.
Okay. Thank you, Gary.
Okay.
Thank you again.